Okay, so next up we have the reverse list. And the basic idea is that we're going to implement recursion in reverse list deep two ways. One is by dealing with nested lists, which we'll deal with later. And then first is we're going to just treat this entire problem as a recursive problem. That is, we're going to take this and call the function on smaller and smaller and smaller sub-problems, like versions of this problem. What does that mean? So we have this list, and we're calling reverse list deep on this entire list. And then what we're going to do is we'll take the first element of the list and move it to the end. And we're going to say we have the latter half of the list, not including the first element. And then we have the first element all the way at the end. And then what we're going to do is we're going to call reverse list on this section of the problem. And then when we call reverse list on that section of the problem, that is going to take everything except the first element of our new and updated problem. And we're going to stick that at the end. And then this, of course, is there from before. And then we're going to reverse this. And then we keep taking the first element, sticking it at the end, and reversing the list on a smaller and smaller and smaller sub-problem until we end up with reversing a list of nothing. And then we have 7, 6, 5, etc., etc. And then we're calling reverse list on nothing, and then we know that we're done. So that's the basic idea. How we would code that is we would say, so first for the recursive case, because I feel like that's the easiest part, what we want to do is we want to separate the first item from the rest of the items. And then what we want to do is we want to return the first item, or the rest of the items, but we want to reverse that, plus the first item. Okay, so that's the recursive case, and then all that we need to implement now is our base case, which is how do we know that we're done? We know that we're done when we're calling reverse list on an empty list here. And so that's exactly what that's going to do. So if we're calling reverse list on an empty list here, then we're going to return an empty list, because when we concatenate our empty list with all of these other one element lists, then we're going to get the full list that we want. Amazing. Now the only thing that we're missing here is support for the case where we have nested lists. So let's say instead of our data, our list looking like this, I'll leave that. We have some nested lists in here. So let's say 2, 3, 4 is in its own list. And then on top of that, let's say that 5, 6, 7 is also in a list. And here we have a doubly nested list. Oh no, how sad. 6, 7 is also a list. So right now we basically only have like 1, 2, 3 elements in our top level list, because each element, these two last elements of the list, are also lists in themselves. And so the basic idea is that we want our resulting list to be 7, 6, 5, 4, etc., and not what this code would do, which would give us, which would just reverse this list as is, not counting for the fact that there are some nested lists. So it would just give us this, which would be sad. And so we want to reverse anytime we encounter an element of the list that's a nested, that's in itself a list, so we have a nested list, then we want to go in and reverse that list too. And as we're reversing that list, if we run into a list there, then we want to reverse that list too. We want to be able to handle any arbitrary amount of list nested depthness. And so that's a perfect call for recursion. So when do we want to check if our element is a list? Well, we want to check when we're looking at just one element. So let's take this, whenever we process the first element of the list, let's check to make sure that that's not a list. And if it is a list, then we'll go in and recursively reverse that. So that's what we're doing here, where we say, we call it new last because we're reversing it. And we're going to replace that here with new last. We're going to go in and recursively reverse that if it's a list. Otherwise, leave it as is. Great. And then that is our reverse list deep code. So just to summarize, we implemented recursion in two ways. First was implementing recursion in taking the first element, moving that to the end, and then recursively reversing the rest of the list. But then we would also have another recursive call, that is, anytime we discovered that that first element was a nested list, like was itself a list, so had lists inside of it, then we would go in and recursively reverse that before moving it to the end.